following has been developed by state and provincial agencies in association with the Agency for Instructional Technology. Together, serving education.
Dad, may I please have the last piece of pie?
Hey, I want it. You got the extra pudding last night.
Pudding's not the same.
Hey, why don't you share it?
There's not enough.
Let's flip a coin. Dad, you got one?
I get heads.
I want heads.
I called it first.
Give her heads and we'll forget about the pudding.
Okay. Tails I win. Heads you lose.
Heads I win.
What are Wendy's chances? That's the question we'll keep asking. Wendy has tails. Her sister Alison has heads. When Dad flips the coin, what are Wendy's chances of winning the pie? Another way to say that is, what is the probability that Wendy will win the pie? Anytime only a certain number of things can happen, and they are all equally likely, you can figure out the probability of a given event happening by figuring out the number of desired outcomes out of the total number of possible outcomes. So when Dad flips the coin, what are the number of possible ways it can land? Heads, tails. Right, 2. Now, how many of these outcomes does Wendy desire? That's right, just 1. She wins with tails. The probability of Wendy winning the pie is 1 out of 2. Each time we stop to ask what Wendy's chances are, remember, probability equals the number of desired outcomes out of the number of possible outcomes.
Okay, everybody ready?
Hey, I want in on
You
this.
didn't even eat the crust on your first piece. I thought you were on a diet.
You don't really want it. That's right. But I could trade it to somebody for washing dishes for me.
Dad, that's not fair. Dad, she wasn't in at the start.
Ah, yes. Solomon must decide which of his starving kids to feed. Miranda has as much right to it as anybody.
Dad! How are we going to flip a coin with 3 people?
We won't. We'll draw toothpicks. This is the short one. Whoever draws it wins the pie.
What are Wendy's chances now? Now that Miranda gets a chance at the pie, the probability of Wendy's winning it has gotten bigger or smaller. If you said smaller, pat yourself on the back, and let's look at why you're right. How many chances does Wendy have to win the pie? That's right, still just 1, only if she draws the short toothpick. But what has happened to the possible outcomes? Well, now there are 3 toothpicks. What's the probability Wendy will win now? 1 out of 3.
Hey, why don't I get in on this?
No!
Don't do it, Dad.
What are Wendy's chances now? How many desired outcomes? That's right, still just 1. And how many possible outcomes? 1, 2, 3, 4 toothpicks. If you said Wendy's chances are 1 out of 4, pat yourself on the back again.
Miranda, you go first.
Do I have to? I'd rather watch Wendy and Alison suffer.
You go first and we'll forget about you not being in from the start.
Neither will you.
Well, I'm the king.
Wait a minute. I'll make a deal with you. If either of us wins, we'll split the pie.
You're the one who said it was too small.
I know, but I'd rather get some pie than none, wouldn't you?
Yeah, but I'll make a deal with you. I'll split it if you cut it and I get to pick which piece I want.
Okay.
What are Wendy's chances now of winning some pie? Granted, she can only win half a piece, but how much has she helped her chances of winning by making a deal with Alison? How many possible outcomes are there? Right, still just 4. But how many desired outcomes does Wendy have now? She wins some pie if she draws the short toothpick or if Allison does. 2. She has twice as many chances now. The probability that Wendy will win some pie has gone up to 2 out of 4.
Dad may be excused.
Don't come back and do the dishes.
So long, Greedy. They're gonna pay for that. You just paid for trying to get the pie and you didn't even want it.
Alison, you're next.
Good luck.
What are Wendy's chances now? Her chances were 2 out of 4, but Miranda drew a long toothpick, and now there's one less, that's right, one less possible outcome. What are Wendy's chances now? 2 out of 3. That's pretty good odds.
Good luck.
What are Wendy's chances now that Allison has drawn a long toothpick? These were Wendy's chances before, but now, how many desired outcomes does she have? Only one, her own draw. The good news is there's also one less possible outcome. Since there are only 2 toothpicks left, the probability of Wendy's winning some pie now is 1 out of 2.
Why don't we just split it 3 ways?
That wouldn't be fair.
Why not?
What would be my chances of winning now?
1 out of 2?
1/2?
You're both right. Well, if my chance is 1/2, and your chances put together is 1/2, why don't I just take half the pie and you 2 split the other half?
That wouldn't be enough.
I heard you say that once before.
Go for it.
You tricked me, Dad. You made this one look longer.
That's not fair, Dad.
I didn't cheat. She picked it. You know, I'm not that hungry. If I gave you the pie, would you share it?
You bet. No problem.
You know, you could have shared it in the first place.
You cut, I'll pick.
That was the old deal.
So what?
Every time we have a new deal, you always have to change it all the time.
In probability, the chance of something happening is always somewhere between 0 and total. Suppose Dad had really tricked everybody and replaced the short toothpick with another long one. Now, whoever draws has 0 chance of getting a short toothpick. But there could be 30 long toothpicks in Dad's hand, and as long as you added 1 short one, you could measure the probability of drawing it. 1 out of 31. That's not much of a chance. On the other hand, what if there were 30 short toothpicks and only 1 long one? What would your chances of getting a short one then be? 30 out of 31. Extremely likely. But does that mean you're certain to draw a short toothpick? In this next story, think about how likely the chances are of things happening.
Wow, look at the swirls. I wonder why Dad had them stuck away in the garage.
They're gonna look beautiful in my aquarium.
Aquarium? Aquarium? I'm taking them to school to play with.
No, you're not. You just lose them.
I would not. Anyway, I found them with you.
Okay, let's split them. I'll take the blue and green. You take the red and yellow.
The red and yellow? You're crazy.
They're more red than anything.
So I want the blue.
But those are the ones that look best in my aquarium. Just think how neat the goldfish will look in front of them.
Tough.
I'll tell you what. Let's put them in here and take turns drawing.
Without looking?
Sure. You might get lucky and draw out all the blue ones.
Okay. There are 12 greens
12 greens.
and 8 blue
8 blue.
20 red.
Wow, I wish there were 20 blue and 8 red.
Me too. And 10 yellow.
10 yellow.
When Wendy picks her first marble, which color is she most likely to get? If you said red, pat yourself on the back again. The reason is there are more reds than any other color. Now, which color is Wendy least likely to draw? If you said blue, there are fewer blue marbles than any other color, which is too bad for Wendy since she wants blue most.
Okay, you pick first.
I wonder what my chances are of getting a blue one.
I know how to figure it out.
How?
Remember how to find the probability of something happening? Probability equals the number of desired outcomes out of the number of possible outcomes. With the marbles, how do you figure out the number of possible outcomes? You add.
Possible outcomes.
So my chance of getting a blue one is 8 out of 50?
Right, Rosie.
I feel lucky. Oh, shoot. Oh, be quiet. I hope you get a yellow one.
Well, Wendy got a red marble, but that was the color she was most likely to get. By the way, what were her exact chances of getting a red one? 20 out of 50, right.
I wonder what my chances are of getting a green or a blue.
I know.
You know?
Yeah, the probability is the number of the desired outcomes out of the possible outcomes, right?
Right.
So, can't you just add them up?
Yeah.
Wendy is right. You can add 12 green plus 8 blue equals 20 desired outcomes. What are Allison's chances of getting either a green or a blue marble on this draw? If you said 20 out of 50, that's pretty good. But you can't pat yourself on the back, not yet, because something has changed. Can you see it? Wendy already drew out one red marble. There aren't 50 possible outcomes now. There are only 49. Allison's chances of drawing either a green or a blue is 12 plus 8 equals 20, 20 out of 49. Well, Allison drew the green marble she wanted. Then Wendy drew 2 straight blues. Then Wendy kept yuck getting red, and Allison kept yuck getting yellow until finally...
I only got 3 blues.
I got 5 blues, but only 3 greens.
I got 9 greens, but so what?
I'll trade you all my yellows and reds for all your blues and greens.
You're crazy.
You're gonna be getting more.
I told you, I want blue. I'll give you my 9 green for your 5 blues if you throw in your reds.
All 13? No way.
You don't want them anyway.
But you do, so make me a deal.
Hey, what you guys got there?
Your dad's all marbles. We found them in the garage.
Wow, they look great with my pot plant.
You wouldn't dare.
I get my share too.
But we saw it first.
With us.
With the coin and the toothpicks and the marbles, you could always count an exact number of both desired and possible outcomes. You might have to think about it carefully, but you could always figure the probability. In many scientific and other situations, it's impossible to determine probability down to exact numbers. But it's still valuable to try to determine how likely different things are to happen. One area in which you see this every day is weather forecasting. To determine the probability of rain tomorrow, or where a hurricane may strike shore, a forecaster needs to consider many complex and changing factors, such as wind speed, wind direction, terrain, cloud types, temperature, humidity, and high and low pressure systems. Put these and other factors together, and thousands of things can happen. Some are more probable than others, but probable, never certain.
And I thought the weatherman said it was going to be sunny today.
MathWorks is a component of the Mathematics for the 80s project and is supported in part by Exxon Education Foundation. This program was produced by John Allman and Art Fitzsimmons under the supervision of the Agency for Instructional Technology.